We go review number 8. Using integers and rational numbers. We're going to talk a little bit about what rational numbers are and how we deal with those. So there are different sets of numbers when we think of numbers, okay? And those go in various degrees. Whole numbers are positive counting numbers. So numbers that we would count with, like when you're a little child, like 1, 2, 3, only positives, and it also includes 0. 0 would be considered a whole number, and that's not normally necessarily counting numbers. We count up to something. Okay, integers are whole numbers, but also include negatives. So positive and negative counting numbers. Okay, the reason we're talking about this is, number one, for some vocabulary, so we could say we're referring to these numbers. If it says give an integer, you know it could be a positive or negative, and it's a counting number. It's a number that is not going to include a decimal. Rational numbers, then, are basically, the formal definition is any number that can be written as a fraction. Okay, and the fraction would be a over b, and b cannot equal 0. And another way to say this, rational numbers are numbers that, like, it can include decimals, right? So now we can talk about some decimals. Any decimal, like if we have 1/2, that can be written as a decimal. That terminates, it ends. So they'll say terminating. Now let me pause for one minute. You guys do have notes at home. I just want to remind you, technically right now, you should be writing all of this with me. I don't write things on the board. I try not to make you write too much. So I don't write things on the board that I don't think is worth your time to write. So please make sure you're thinking through that. It helps it to go in your head. It helps you to process it, and then you have it to refer back to later. So they could be terminating, or if I had something like 1/3, right, that's 0.333, and it goes on. Sometimes we write it like this, 0.3 with a little line above it, if you remember that. And that basically would be a repeating decimal. Okay, so rational numbers are any number that can be written as a fraction, which would include terminating decimals and repeating decimals. Now, before I go further, I do want to make sure it's clear to you that each one of these categories includes the previous. The integers includes the whole numbers, right? If something is a whole number, it's also an integer. If something's a rational number, it includes whole numbers and integers, right? Any counting number, I could take the number 5, and I could write that as a fraction. Note, watch how I do this. Ready? 5 is equal to 10 divided by 2. Okay? And so you can write it that way. Right? And real numbers basically include all of these and then another category. Okay, so real numbers are all of these, but they also include something called irrational numbers. Included. Okay, so it's taking all of these guys. Again, don't forget, it's going to include everything up here, but it also includes these things called irrational numbers. For now, we're not going to take a ton of time to talk about those. Simply put, I will say it is a fraction that doesn't meet one of these qualifications. So it has to not meet both. So it's not going to terminate, and it's not going to repeat. The most famous one, if you could think of it that way, is the number pi. Pi is an irrational number. It never ends. It never repeats. Okay? All right. So now that we have those, they kind of work like these overwhelming circles. You have whole numbers here, right? And the integers include the whole numbers. Integers. and then your rational numbers, and then your real numbers. Okay, and again, real has all of these things inside of it, but then it also has numbers like pi that are floating out here. There's other numbers like this that are irrational that fit into that category. So it's just helpful to kind of visualize and see kind of the way it's going to break down. Okay, so it just asks us, just kind of working with those, we want to be aware, tell what sets of numbers the following belong to. So they want to know, they want to make sure you understand, like, what does this fit into? So this would be a whole number, an integer, a rational number, and a real number. This is all of the categories. It fits into all of them. Okay. This one, it's not a whole number, it's not an integer, but it is a rational number. Notice it does not continue, just 0.6. Okay. And it is a real number. So basically all of the numbers, unless I've slapped pi up here, everything's going to be real. Real is going to fit every category, again, unless I put something like pi. Okay. This one right here is going to be rational and real. Again, it's not a whole number. It's not an integer because there's just a decimal there. But it does repeat. If I wrote this as a decimal, this would be negative 2.666 repeating. That's where it's going to be the rational number. And this last one would be an integer. It's a whole number that's negative, right? So we can't call it a whole number, right? So it's a number with no decimals. Number with no decimals. But that is a and a negative. So that's making it an integer. No decimals with a negative is an integer. It's also real, and it's rational and real. And again, you could see once it's one thing, it's everything above that as well. So the moment I write I, it's R and real, right? And you can see that kind of how this works. If it's in the whole, it's in all of these circles. If it's in the integers, it's in the ones above that. So on and so forth as you work your way out. Okay, so this one I want you to try here. Go ahead and put these, put the categories that they go through. You can pause the video. On EdPause, I'll put a little question. I'll ask about one of these just to see what you get, and then the answers will be up afterwards. All right, this is what you should have gotten for those. Hopefully, there's not too much confusion there. I do want to talk about this again. I want to make sure for the decimals we really understand. Because there's nothing else after this, it's just stops. That's what makes it a rational number. Okay, there's no repetition. There's no repetition here. I don't even have to worry about that. But this is a terminating, a ending. It stops decimal. Okay. Right. Then within that, we have these things called kind of thinking about some of these numbers. You have opposites of numbers, right? When we're talking about numbers, we want to be aware of what the opposite of that is, because as we learned in a previous section, the opposite of a number is kind of like its inverse. If we think about it for addition, it's additive inverse. So two numbers that are the same distance from 0 are called opposite numbers. Oftentimes we'll put the opposite is denoted as a negative. So the opposite of 3 would be negative 3. They're the same distance from 0. If you think about a number line, if 0 is here, positive 3, 3 spaces over this way, back to 0. Negative 3, 3 spaces over this way. So they're opposite. So you can see the opposite of A is negative A. So that's where they're getting that from. And absolute value tells you, the distance a number is from 0. And so basically, absolute value, it's a symbol you write like this, takes any number, let's just stick with 3, and tells you how many spaces that number is from 0. So think about a number line for a minute. Here's 3. 1, 2, 3. Sorry. Let's try that again. So the number 3 is 3 spaces away from 0. Okay? But if I also let's put up the number negative 3 here. Okay, absolute value of negative 3. When we're talking about this, I'm just counting spaces. 1, 2, 3. That's also 3 spaces. So absolute value basically ignores positive and negatives. Okay? It only looks at the number of spaces. Well, spaces or distance measured is always a positive. If I pull out a tape measure and I put it on this side of me or this side of me, the numbers don't change. It doesn't say like positive on this side, negative on this side. It just always has the same numbers. Or think of another way. If I hop in a car and I start driving, the odometer changes. And if I put my car in reverse, it's not like all of a sudden the odometer starts to go down. It doesn't get smaller. The numbers grow. If I'm driving backwards, my car still tells me I'm driving more miles. So when we're looking at this, whether we go to the right or to the left, the number of spaces, the distance, is always a positive. And so that's what absolute value does, is it basically gets rid of those negative numbers for us. Okay? So it says find the absolute value of every number, and all we're going to do, if it's a positive number, the same, that's how far away it is from 0. But if it's a negative number, okay, the absolute value of this, let's say I should put those symbols on there. That's the absolute value. It's 2 kind of longer lines there. If it's a negative number, all you're going to do is make it positive. You're not ignoring, but you're recognizing that what those lines do is say how far away from 0 is it in terms of distance. So it's going to be a positive number. Okay. Absolute value gets rid of that. Now, if they asked me for the opposite, let's say I came up here and I said, what is the opposite of all of these numbers? The opposite of 5 is negative 5. The opposite of 0.6, negative 0.6. The opposite of negative 2 and 2/3 is positive 2 and 2/3. So if it's negative, it becomes positive. If it's positive, it becomes negative. So you're going to do the opposite, right, of what you started with. Okay. Again, that's what we're saying here. So the opposite, I was just doing those. The last one would be opposite would be 24. Sorry, I did that on the last slide. Okay. But again, it's just going to change the sign. So sometimes, like on this one, the absolute value and the opposite are the same. Okay. You can kind of see that here. The absolute value, 2 and 2/3. The opposite, 2 and 2/3. Okay, but here, the absolute value is 5. The opposite is negative 5. You want to make sure you catch that change. They're not always the same. So, all right. This one just says evaluate, and they're asking us to plug in something. They've been doing this all along. So if I take negative x, right? This is what it says, negative x. And I put it in parentheses for a minute because I want us to see what's supposed to go in here is negative 2.1. So this negative here is outside, and then all of a sudden I have negative here, and so I do this. So it's negative 2.1, or the opposite of negative 2.1. It's just a way for us to write the opposite, is to put that negative in front. So my answer becomes positive 2.1. Another way to think of this is think of this as multiplication. A negative times a negative is a positive. Okay. So this one, same thing, we're going to plug this in. Absolute value of negative 2.1 plus negative 2.1. Okay. If you want to put that in parentheses, that's how I'll normally write it, just so we understand. There's 2 signs here. Okay, the absolute value is going to take my answer here. It's going to make it a positive number. That's how far away negative 2.1 is from 0. It's 2.1 spaces. And then I'm going to add a negative 2.1, which adding a negative, let me just write this again, is the same as subtracting. So 2.1 minus 2.1, or 2.1 plus negative 2.1, is 0. Alright, so just make sure you're including the signs carefully and paying attention to what each one does. I'm not saying this is easy. It really is a matter of you taking the time to carefully walk through this. This is where showing your work is really important, that you're taking the time to write each number, each symbol, and then process through and think through those things. Okay. At the end, I've been having these U-tries. I do want you to try to figure this out. It says, does the order change depending on whether x is positive or negative? So these are numbers. You've got x, and then x plus 3, and then x minus 2. And they're saying put those on a number line. So here's the deal. What I would encourage you to do is pick a number. Pick a number like 5 or 3 or 2. Don't pick the number 0 or 1. But pick another number. Okay, let's just say we pick 5 and plug it in here. What if I plug in 5? I would get 5, I would get 8, and I would get 3. So clearly if I put these on a number line, this is the smallest, this is the medium, and this is the large, if I could think of that way. Now they're saying, what if you plug in -5? Does that change the order? So I'm going to let you guys figure that out, see what you come up with. Why don't you stick with 5? And figure out if the order would change. Would this still be the smallest? Would this be the medium and the large? If you put those on a number line using a positive and using a negative. All right. I'll get some feedback from you in the video, and we'll pick up a little bit more tomorrow.